हाय फ्रेंड्स, मेरा नाम अक्षोभ्य है। आज हम मेरे सिविल जनरल के यूट्यूब चैनल के माध्यम से असिस्टेंट इंजीनियर सिविल इंजीनियरिंग के एग्ज़ाम की प्रिपरेशन वीडियो लेक्चर्स द्वारा करेंगे। ये वीडियो लेक्चर्स स्टेट पीएससी एंड पीएसयू के असिस्टेंट इंजीनियर के एग्ज़ाम के प्रिपरेशन के लिए काफ़ी उपयोगी सिद्ध होंगे। ये वीडियो लेक्चर्स बेस्ड हैं मेरे द्वारा लिखे गए बुक ए सिविल इंजीनियरिंग की थ्योरी कॉन्सेप्ट्स एंड सॉल्व न्यूमेरिकल्स वॉल्यूम 1 के ऊपर। इस वॉल्यूम 1 बुक में इरिगेशन इंजीनियरिंग, हाइड्रोलॉजी और सर्वेइंग के टॉपिक को कवर किया गया है। तो चलिए शुरू करते हैं पहले टॉपिक इरिगेशन इंजीनियरिंग से। इरिगेशन इंजीनियरिंग टॉपिक्स 7 चैप्टर्स में डिवाइडेड है, जिसमें पहला है इरिगेशन सिस्टम। तो चलिए शुरू करते हैं। इरिगेशन सिस्टम टाइप्स ऑफ इरिगेशन। इरिगेशन में ब्रॉडली बी क्लासिफाइड इनटू पहला सरफेस इरिगेशन एंड दूसरा सब सरफेस इरिगेशन। फॉलोइंग आर टाइप्स ऑफ सरफेस इरिगेशन। पहला बॉर्डर इरिगेशन, दूसरा फूरो इरिगेशन और तीसरा बेसिन इरिगेशन। स्प्रिंकलर इरिगेशन इज नॉट अ surface irrigation method. Surface irrigation can be further subdivided into flow irrigation पहला और दूसरा lift irrigation. Well irrigation is a type of lift irrigation. Subsurface irrigation. The system of subsurface irrigation can be employed usefully under the condition for places having high groundwater table, for places having impervious soils occurring at a depth of 2 meter to 3 meter below the ground surface, and for places with moderate land slope. Subsurface irrigation has the maximum water application efficiency when compared to surface irrigation, lift irrigation and sprinkler irrigation. In subsurface irrigation method, water is directly supplied to the root zone of the crop. Techniques of water distribution in the farms. पहला है free flooding or ordinary flooding. Where steep land is available, the method of irrigation used is free flooding. Border flooding दूसरा. Border flooding method of application of water may be suitable for rolling land. In border strip method of irrigation, the width of a strip is 10 to 20 meter. तीसरा है check flooding. Levees are generally constructed along the contours having vertical interval of about 5 to 10 cm. For cereal crops, the commonly adopted method of irrigation is check method. चौथा है basin flooding. This method is a special type of check flooding and is adopted especially for orchard trees. पांचवा है furrow irrigation method. The method of growing crops on ridges running on the sides of water ditches used in certain agricultural fields is called as furrow irrigation. Furrow irrigation is water passing through narrow ditch. In furrow irrigation, the depth of furrow from ground level is kept as 20 to 30 cm. छठा है sprinkler irrigation method. Method of irrigation in which water is applied in the form of a spray as in ordinary rain is known as sprinkler irrigation. Sprinkler irrigation is not suitable to rice because rice has huge water requirements during its growth. There is minimum wastage of water in sprinkler irrigation as compared to furrow irrigation, check basin irrigation and border method. Sprinkler irrigation मेथड अभी कंटिन्यू किया जा रहा है. स्प्रिंकलर इरिगेशन इज सुटेबल व्हेन लैंड इज स्टीप एंड सॉइल इज इजीली इरोडेबल. द सुटेबल मेथड ऑफ इरिगेटिंग in arid areas with uneven land surface, most suitable method of irrigation is sprinkler irrigation. The suitable method for irrigating highly modulating land is sprinkler irrigation. For standing crops in undulating sandy fields, the suitable method of irrigation is sprinkler irrigation. Sprinkler irrigation is an irrigation method for which the following statements are made. पहला, this method does not require preparation of land before irrigation. दूसरा, it prevent waterlogging and provide optimum irrigation. तीसरा, initial investment and power requirement is high. चौथा, strong wind will disrupt irrigation application. Next, condition favoring the adaptation of sprinkler irrigation method is when the water is available with difficulty and when the land soil is excessively permeable or when the soil is highly impermeable. The maximum Application by sprinklers is limited by infiltration capacity of the soil. Seventh one, drip irrigation method. Drip irrigation is used in arid and semi-arid areas. The highest water-saving method of irrigation is drip irrigation. Trickle irrigation is also known as drip irrigation. For irregular topography, the most suitable method of irrigation will be drip irrigation. In an orchard of mango trees, the most suitable method of irrigation is drip irrigation. The most suitable method of irrigation for areas having low rainfall and strong winds is drip irrigation as compared to sprinkler irrigation, furrow irrigation, and free flooding. Sub irrigation, furrow irrigation, and check irrigation methods of irrigation use open ditches for water delivery. Triple, Trickle or drip irrigation does not use open ditches for water delivery. This method applies water in the forms of drops directly near the base of the plant. Next, controlled flooding. Ring basin, check basin, and border strip are all methods of controlled flooding in irrigation methods. Contour is not a method of controlled flooding. Next, elimination of mixed cropping. Elimination of mixed cropping is an advantage of irrigation. Mixed cropping is eliminated where irrigation is assured. Generally, mixed cropping is adopted in the areas where irrigation is not assured. The purpose of mixed cropping is to increase fertility of land. Introduction to irrigation system. IHP stands for International Hydrologic Program. The total volume of water on Earth is estimated around 1.386 billion cubic kilometer. The percentage of total quantity of fresh water available in the world of either in the liquid state or in the frozen state is about 2.5%. ASTRA stands for Application of Science and Technology to Rural Areas. As per 210 World Bank data, 35% of agricultural land is irrigated in India. A medium irrigation product has CCA between 200 to 10,000 hectare. Next, quality of irrigation water. The salt concentration in irrigation water should not exceed 2000 ppm. The quantity of sulfates ppm contained in good quality irrigation water is 0 to 192. Sodium absorption ratio SAR is defined as SAR is equal to Na plus divided by Ca double plus Mg double plus, where Na plus Ca plus and Mg double plus concentrations are in milligram per liter. For irrigation water having SAR above 26 is not used for any irrigation. The salt concentration in irrigation water is generally measured by electrical conductivity value. For irrigation purpose, the pH value of water should be between 6 and 8.5. A soil can be considered as practically infertile when the pH reaches a value of 11. Irrigation water having sodium absorption ratio SAR of 12 is classified as medium sodium water. SAR value between 10 to 18 indicates medium sodium water. Now friends, we will see the numerical parts. The first numerical is, the question is, a sprinkler system is to be provided to apply water at a rate of 1.25 cm per hour. Two 186 meter long sprinkler lines are required. 16 sprinklers are spaced at 12 meters interval on each line. The spacing between lines is 18 meters. The required capacity of a sprinkler system will be, options are A 30 liters per second, B 24 liters per second, C 18 liters per second, and D 12 liters per second. Answer is, the solution is as follow. Discharge of an individual sprinkler Q is equal to ST into SM into L by 360, where ST is spacing of sprinkler along laterals, SM is spacing of laterals along the main, and I is optimum application rate. So Q is equal to ST, that is 12, into SM, that is 18, into I, that is 1.25 divided by 360. So Q comes to be 0.75 liter per second per sprinkler. System capacity will be equal to total discharge of all sprinkler, that will be equal to 0.75 into 32, that is equal to 24 liters per second. Second numerical is a tube having a capacity of 4 meter cube per hour operates for 20 hours each day during the irrigation season. How much area can be commanded if the irrigation interval is 20 days and depth of irrigation is 7 centimeter? Options are A 1.71 into 10 to the power 4 meter square, B 1.14 into 10 to the power 4 meter square, C 22.9 into the 10 to the power 4 meter square, and D 2.29 into 10 to the power 4 meter squares. Now let's see the solution. Q is equal to 4 meter cube per hour for 20 hours each day. So discharge Q for 20 days will be 4 into 20 into 20, that is equal to 1600 meter cube. Area will be equal to discharge by the irrigated depth. Discharge is 1600 and irrigated depth is 7 into 10 to the power minus 2. So the area will come to be 2.29 into 10 to the power 4 meter square. So this was the first chapter of irrigation engineering. Tomorrow we will see the second chapter, that is water requirements of crops. Thank you, and please do not forget to like, share and subscribe and hit the bell icon. Thank you.